let's look at the readiness homework number 2. I'm going to kind of split my screens. All right, the first one says evaluate the expression. So whenever you're evaluating an expression, you are substituting in. So if I have 6x minus 3y, when x is 4 and y is 3, I'm going to sub in a 4 for x and a 3 for y. So it's going to be 6 times 4 minus 3 times 3. So I use parentheses for that. So I'm going to put that in the calculator. So it equals 15. So we are just substituting in the values. Same thing here, but we have fractions. So like the last video, you have to get a common denominator in order to do those fractions. So we have 15 over x plus 10 over y when x equals 5 and y equals 2. So it's going to be 15 over 5 plus 10 over 2, which actually is a little easier than finding a common denominator because you can divide those. 15 divided by 5 is 3, and 10 divided by 2 is 5. So we're actually just going to add them. That makes it easy. Write the following phrase as a variable expression. Use x to represent a number. So 12 times a number decreased by 2. So it's like you would imagine 12 times a number. So 12x decreased by 2 minus 2. 12 less than the product of 2 and a number. So that less than the product of something, less is actually a turnaround word. So we are actually going to subtract 12 from whatever it says after that. So it's called a turnaround word, less than the product of. So product means multiplication of 2 and a number. So it's actually the opposite. So that was actually 3. Got my counting off a little bit. Okay. Determine whether the given number is a solution to the equation. So it's saying, is 6 a solution to the equation? So we have 6a minus 7 equals 4a plus 5. To determine if 6 is a solution, we would substitute it in and see if it was true. So I'd say 6 times 6 minus 7 equals, so I don't know if it's equal, so I kind of put a question mark there, 4 times 6 plus 5. So we could put that in the calculator or we can work it out. Either way, 6 times 6 is 36, minus 7 is 29. 4 times 6 is 24. 24 plus 5 is 29 also. I'm just going to show that with the calculator though. So if it is equal on both sides, it is a true equation. So this is yes, it is a solution. 6 is a solution. Same thing on that one. Write the sentence as an equation. So is means equals. Gives is equal. So anytime you see is or gives or equals, you'll put the equal sign there. The bar graph shows the average price of a movie ticket for select years from 1980 to 2010. I'm going to read it to myself the rest of the time. Okay, so these are the years, and T is average movie ticket price in number of years after 1980. So it wants to know, according to the model, so the model, let's Number 9. The model is the equation. T equals 0.14 n plus 2.97. So we wouldn't put the year here. We would put in years after 1980. So it's 10 years after 1980. So you'd substitute this in. So whenever you substituted that in, where I put in 10 here, T equals 4.37. So that's how much it's saying, $4.37 would be the average ticket. So we would put that here. Okay. And there's actually a part B. Does the mathematical model underestimate or overestimate? So does this model, this is our model, does it over or underestimate? So look at this. The actual is 421. So the model overestimates. And to find out by how much, you would subtract what the actual was. So this was the model, and this was the actual. Oh, added an extra thing. So 16 cents. Oh, let's see. Does the model... So you would also have to do it where on 2010. So make sure to do that. So we did the 1990, and then you have to do 2010. For 2010, it would be years after 1980. That would be 30 years. So N would be 30. Okay, list all the numbers. We've done one like this before, I believe, where it talks about what kind of numbers there are: natural numbers, whole numbers, integers, rationals, irrationals, and reals. So you'll need to look up what those are, and you're going to list out each in this set. Same for that one, same for that one. How many terms are in the expression? So terms are the items that are separated by plus or minus. So we have 1, 2, 3 terms there. What is the numerical coefficient of the first term? So here's our first term. It doesn't have one, so it's understood 1. What is the constant? Constant does not have a variable, so 7 is your constant. Does the algebraic expression contain like terms? If so, what are the like terms? So the like terms are the ones that have the same variable and exponent. So x and 5x are your like terms. So x, comma, 5x. Okay, so there's another one similar to that. Okay, distributive property is whenever you see a number outside parentheses, when you have 2 or more terms inside here, that means that this number on the outside is going to be multiplied by every term on the inside. So I'm going to multiply the 4 times the 3 and the 4 times the 2. So 4 times 2x is 8x. And then 4 times 3 is 12. And then if you have more than 2 terms, you have to do that as well. So 2 times the 8x, 2 times the negative 4, and 2 times the 3y. This one, there is no distribution because it's just plus parentheses. So that plus doesn't even need to be there. No, the plus does, sorry. The parentheses doesn't. So the parentheses, there's nothing out front of that. It's understood 1, but multiplying 1 times anything is not going to change it. So I can remove the parentheses. And then I could look for my like terms, which in this case would be my constants. I want to put my x first. That's how mathematicians do it. They put the variable first and then the constants as the next term. So 4 and 18 make 22. Combine like terms on this one. You would combine your x's by doing 3x plus 3x, making that 5x. And then 8 and a negative 7 would be like 8 minus 7 to get 1. Do the same thing here. Combine x's with x's and y's with y's. This requires, let's see. Let's go ahead and work out this one. 7 parentheses 4y plus 5 plus a negative 3y, 31y. Okay, so the left, or the terms on the left side, this needs to be distributed. 7 times 4, 28y. And then 7 times 5, 35. And then there's nothing that needs to be done here except remove the parentheses. And I just went ahead and removed the plus too, because that negative, I can just get rid of the plus and I just have the minus sign there. Then combine your like terms. So the 28y and the negative 31y. When you have different signs, you subtract and keep the sign of the larger. So 31 and 8, there are 3 between them. And then you want to keep the sign that's larger. And that's the 31, so y plus 35. $21. I'm going to go ahead and work this out. Anytime you see a minus, a negative here, and there's just one term right here, you're just going to keep change, or keep change, flip, because this is a double negative. Minus a negative actually means plus. So this is 13 plus 10x plus 5x plus 11. And then combine like terms. So you combine the 10x and the 5x. And then separately combine the 13 and the 11. So you would need to combine like terms on this one as well. Look for your same signs, same variables. Okay, the next one we would distribute the negative 4. So if you have to distribute a negative 4, you're multiplying negative 4 times a negative 2. Let me go ahead and write this one down. So you're going to distribute not just the 4, but the negative 4. Make sure you multiply it times both terms. So negative 4 times a negative 2 is a positive 8x. Negative 4 times a positive 2 is a negative 8. And that's all I can do because these are not like terms. Okay, let's look at this one. So this has 2 parts where you're going to have to distribute. So first thing you're going to do is distribute that 3. And then we have this negative out front, which is this understood 1 right here. So you're actually going to multiply the negative 1 times everything inside. Negative 14y. And then negative 1 times a negative 1, which gives us a negative 1. And then combine your like terms. 15y minus 14y. That'd be 1y. And then a negative 6 minus 6, negative 7. And you don't have to have the 1y there, so it could just be y minus 7. Okay, determine whether the given number is a solution to the equation. You will substitute in 11 on both sides and see if it comes out to be the same. So I did one like that, similar to that earlier. Same thing there, plug in the negative 12, see if they come out to equal the same thing. Simplify the algebraic expression. So on this one, we actually have like terms because they have the same variable and exponent. So whenever you do that, you just add your constants, or I guess coefficients. You should add your coefficients. So if I have 6x, 27, 6x cubed plus 11x cubed, we are just going to combine the numbers. So 6 plus 11 is 17x cubed. You do not add your exponents. Okay, same thing. Okay, order of operations. So PEMDAS. A lot of you probably remember that. Parentheses, exponents, multiply and divide from left to right, and then add and subtract from left to right. So this is question 29. We have 7, parentheses 3 minus 5, parentheses cubed, minus 3, 6 minus 8 cubed. So PEMDAS, so we're going to start with parentheses. So we're going to do what's inside. 7. 3 minus 5 is negative 2 cubed. Minus 3. 6 minus 8 is negative 2 cubed. So parentheses is done. Exponents, negative 2 cubed. Negative 2 cubed means negative 2 times negative 2 times negative 2. You can use your calculator on this, but I am going to show you how it comes out to be a negative answer still. Negative 2 times negative 2 is 4. 4 times negative 2 is a negative 8. So this is going to be 7 times a negative 8. Minus 3, that's the same thing, so times a negative 8. 7 times a negative 8 is negative 56. Negative 3 times a negative 3 is positive 24. So even though this said minus 3, because this comes out to be a positive number whenever I multiply negative 3 times a negative 8, I'm going to put up plus 24. So 7 times 8. Okay, so 56 and 24. The difference between them is 32. Then you'd keep the sign of the larger number, so it'd be negative 32. Okay, parentheses and brackets are kind of the same thing. So you would want to do the innermost parentheses. So within this parentheses, you're going to do exponents first. Evaluate the expression for the given variable. So plug in the negative 5. What's confusing about this one, though, is that we have a negative x squared minus 2x. And then we have that x is negative 5. So I have a negative, but then I have a negative 5 squared minus 2 times a negative 5. So you can plug that in. I'm going to come over here because I've kind of run out of room. Negative 5 squared is a positive 25. But because we have a negative out front, it's going to be a negative 25. And then negative 2 times a negative 5 is a positive 10. Negative times a negative makes it positive, so it's going to be a plus. Different signs, subtract to keep the sign larger, so negative 15. Okay, you're going to have to sub that in as well. And you can be using your calculator, checking this out, learning more about the calculator. I think it's a great thing to be able to use that calculator. Sometimes it'll be easier, sometimes it won't be. So let's see on this one. This is number 32. 8y minus 4y squared over y squared minus 12, where y is 3. So what you can do is you can plug in the 3 here. And if you have a newer calculator, an 84 that's been updated, if you've recently bought one, you can do this. You can do the alpha y equals, and it comes out to where you can use fractions. Did y'all see that? Alpha y equals, I have a really old calculator, so that's why it's written like that. And so I'm going to do 8 times 3 minus 4 times 3. The squared button's right here. Squared over, I'm going to keep, every time I put in 3, I'm going to put in parentheses. Minus 12. It comes out to equal 4. Express the sentence as a single numeric expression. Use order of operations to simplify. Subtract 10 from 6. Multiply this difference by 2. Square that product. So subtract 10 from 6. So subtract 10 from 6. So it's going to be 6 minus 10. Multiply this difference. So here's this difference by 2. Then whatever you get there, you're going to square it. So you're going to write it and then actually find out what that equals. Cube means to the third power? Yeah. Okay, solve the inequality below. So for inequalities, so let's see, x is greater than or equal to -3. So something that y'all need to know, so here's your notes, is anytime you have less than or greater than, it's going to be an open circle. Well, on these, they're actually brackets, open bracket. Less than or equal to, no, it's a parentheses. Parentheses. The or equal to is the bracket, sorry. What I was trying to say is open circle, which is the same as parentheses. Closed circle and bracket are the same. And then the direction that it goes, like this is a less than, it's going to go left whenever you graph it. So x is less than 3. So that means we have 3, 4, 2, 1, you know. You're going to have a parentheses, and it's going to go less than. See how this arrow? It's going left, left, less than. It's going to go this direction. So you're going to put a parenthesis, and then it's going to go that direction. The way I tell my students is you look at what direction the inequality is. As long as it's x something, a number, you can do it this way. So something being less than, greater than, less than, equal to, greater than, equal to. You can use the inequality symbol to decide which direction it goes. So this way is going to go, it's greater than, it's going to go right. And it's going to be a bracket. This is less than, it's going to go left, and it's parentheses. This is a greater than, so it's going to go right. See how it's going right? That's an arrow pointing right. It's going to be a parentheses, and this is less than, it's going to go left, and it's going to be a parentheses. So this one is going to be at -3. So let's think how these numbers go. So we're on the negative side. So this is a greater than symbol. It's not left. It doesn't look like my left hand. So it's going to go right. And it's going to be a bracket. See how this is the same thing as this. Okay. And then this is the compound inequality. So -5 is less than x is less than or equal to 3. Anytime we can do it like this. So we have this 3, 4, 5. 2, 1, 0. Oh, it's all the way over here, -5. So right here, it's less than or equal to. So I know it's going to go that way. It's a bracket. See how these are the same inequalities? So that means I'm going to do an inequality over here, but this one's parentheses. So it's just the numbers between them. As long as the numbers in the middle and then it goes less than to greater than, and these are less than symbols, then you're going to shade between. If it was the opposite way, you'd shade going opposite directions. There might be one like that too. Nope. Okay, exponent rules. So x to the 9 times x to the 5 times x to the 3rd. Anytime you're multiplying exponents, you're going to add. Multiply exponents, add. Multiply, not exponents. Multiply like bases, that's what I should say. If you multiply like bases, you're going to add the exponents. So you're going to add these. Because what this means is there's 9 x's, 5 x's, and 3 x's. So all together, that makes 17 x's. Okay, the other rule, this is called the power rule, because it's a power to another power. Power to a power. And in this case, you are going to multiply your exponents. So this would be x to the 77. If there's a number inside the parentheses, you have to send the exponent into both numbers, or the number and the variable. So this and this. So it's going to be -2 squared and x squared. -2 squared is 4, so 4x squared. So don't forget about that -2. It is being squared also. So you can only deal with like bases like this. Like I can't add 9 and 8 and say that's my answer. Sorry, that was the school bell. So instead, this is a problem about dividing like bases. So if you multiply like bases, you add. If you divide like bases, you're going to subtract your exponents. So 4 to the 9th over 4 to the 5th, and 3 to the 8th, and 3 squared. So we would subtract the 9 and the 5, so it'd be 4 to the 4th, and the 8 and the 2 times 3 to the 6th power. Okay, let's see. We've got a few more left. So you got to follow those same rules. Anything to the 0 power equals 1. So let's say a to the 0 power always equals 1. Anything to the 0 power equals 1. So if I have a -4 to the 0, that equals 1. This one, you still have a negative out front. So the 9 to the 0 is 1. Carry down the negative, it's a -1. Okay, you're going to have to send in that cubed power to everything on the inside. So -5 cubed over 3 cubed, and then a to the 5th cubed. So -5 to the 3rd power means -5 times -5 times -5. And you can use your calculator. Comes out to -125. 3 cubed is 3 times 3 is 9. 9 times 3 is 27. And then to the 5th power, to the 3rd power, that's the power rule. So we're going to multiply those. So a to the 15th. Okay, you're going to have to do the same thing. Send that squared into the 7th and into the 4th, into 6, so it'll be 6 squared, and then to the z. A negative exponent is actually where you're going to flip the fraction. So 6x to the 4th over 3x squared, all to the negative 3rd. Anytime you have a negative exponent, it's the whole fraction. I'm just going to flip them. And I'm going to do this to the positive 3. So then I'm going to have to send that into everything for the exponent. Okay, so on this one, we're going to do 1 over a negative 2y to the negative 1, and then all of this to the 3rd power. That's a lot, right? So then this is 1 over negative 2 cubed y to the negative 3, because I'm going to multiply those. So then this is actually going to come up, and it's going to be y cubed over negative 2 to the 3rd power is going to be a negative 8. So anytime you have a negative, you always move it from the bottom to the top or top to the bottom, flip it around. Greatest common factor. So you're going to have to find out the number that will divide each of these equally. So I would first look at the numbers. So what number divides all of these equally? 2 does, because they're all even. 3 doesn't. 4 divides this one, divides this. So 4. So this is called your GCF. So it'd be a 4. Not all of them have negative, so I wouldn't put a negative. And then with the variables, you actually take the smallest variable that they all have in common. So in this case, it's just a y. And you can have an x's and y. So you'd look at 12, 9, and 15. And then I think 3 divides all of those evenly. And then x's, we have x5, x3, x4. The smallest one is x3. So it would be 3x3. And then y squared, y5, y3, be y squared. 3 divides all of those numbers equally, and then we take our smallest variable exponent. For which values of x is a radical expression or real number? So the thing is with real numbers is if I have any kind of negative number, negative n, that's going to be not real. So what would make this equal to a negative number? 0 would be okay, but anything smaller than 0 would not work. So what we're going to do is we're going to set this. Actually, we're not even going to use the square root. We're just going to say x plus 2 equals 0. So what's going to make it equal to 0 when we solve it? X equals negative 2. So x has to be greater than or equal to negative 2. Because anything smaller than that is going to give me a negative number. So let me make sure that this works. So I'm going to go ahead and plug it in. Okay. So you would set whatever's inside this radical equal to 0 and solve, and make sure that that value, x, is greater than or equal to whatever that value is. All right, that is all that I have for you for the readiness number 2.